four options were there, none of the above.
Yeah.
Sensitivity, for sensitivity, all the other three had some unit. Sensitivity cannot have unit.
Mm.
So answer would be none of the above.
Mm.
Whereas they have shown one particular answer with 1.85.
Yes. Like
Ki-
there were more than one problem, I guess. I
yeah, yeah,
didn't see in one more
yeah.
question was there. I think there can be two options in that. So whatever
Right.
problem you have facing, you will get the marks for those questions, no issue.
Yeah, yeah.
And the solved assignments for those will be uploaded soon by the other TA.
Very good, very
Mm-hmm.
good. So I was surprised,
Mm-hmm.
sensitivity.
Yeah, yeah.
This has the,
Sometimes like.
what is the problem?
Mm-hmm.
This has the effect of misguiding the learners who do not know it so well.
Yeah, yeah, yeah.
They will take it to be correct from some
Mm-hmm.
IIT, wonderful. So they will go by this kilopascal. From that
Uh,
angle, I am telling.
okay.
I know
Yeah, yeah.
that this is not correct.
Yeah.
I have 46 years behind me,
Hmm.
but these youngsters who are final year B or something like that, they will not understand all this.
Yes, yes.
That is the problem. So it's our duty to tell them.
Hmm. Yeah, I hope he will not do mistake again. Like.
There was one more course.
Hmm.
uh, Every time there will be some error. Then they will come. Oh, sorry, this. Many assignments had
Hmm.
erroneous answers.
Okay.
Then they had to reevaluate. It happened in two, three assignments. Then in my
Oh.
feedback, I wrote
Uh-huh.
that people concerned should be able careful. They are paid for all this, no?
Yes,
Just
yes.
like that, they throw away and then say,
Mm-hmm.
"I'm sorry." At IIT level, this should not happen.
Yeah, yeah.
In a small, middle level, low level college, it can happen.
Hmm.
Teacher may not know himself, but person is at the top. That top
Yes.
person is not supposed to commit mistakes again and again.
Yes, I'm
So
getting your point.
normally
It should not be expected
Normally,
from.
normally, I'm the last to write anything because in Central PWD we had been dealing with all sorts of people, bad also.
Yeah.
So we are very careful about writing. You have to take work from those people only. So I'm the last person to comment adversely against anybody.
Mm-hmm.
But in that case, I was constrained to write that this should not happen again and again. Once it can happen, okay, again, then say sorry, this is mistaken. This is total confusion.
Hmm. Yeah.
This happened in one course. One of the IITs was doing that, probably IIT Kharagpur.
Okay.
Again and again, same thing.
Yeah.
In Institute of Science, I am indebted,
Hmm.
one of the top experts who interviewed me was N.S. Govinda Rao.
Okay.
With B to his credit, he was from Water Resources, top man in cavitation.
Mm-hmm.
With B to his credit, he produced 16 PhDs. He became HOD in 51, 52 when I was born,
Okay.
and then he became director of the same institute also,
Yeah.
without masters, without doctorate.
Ah. Okay.
And C.V. Raman never held any earned
Yeah.
doctorate,
Yeah. Yeah. Yes.
only masters, and guided so many big PhDs.
Yes.
So this has a great history. I
Mm-hmm.
also tried to come there.
Mm-hmm.
In ME, I was selected. I did not come for interview. At PhD level, I tried, but I went for a problem. They directed me to aeronautical. I went for acoustic emission technique. I wanted to apply on rocks, etc.
Mm-hmm.
Aeronautical engineering, there was something written on notice board. No intake in NDT this year. So neither here nor there. Then I ended up in IT Madras.
Okay. It's fine. No issue. Sometimes it happens.
So NS Govinda Rao interviewed me in
Okay.
76. He came on wheelchair, 85 years old at that point of time.
Yeah. Professors here are having so much of dedication and all with their work.
Yeah,
I must say. Yeah.
I had close touch with CG Sitaram, then uh, PS Nagraj.
Mm-hmm.
We were in technical committee here in IGC 2001.
Okay.
He came all the way from Bangalore. Good interaction with Professor PS Nagraj. So with geotech people, most of them I had good interaction. Dr. Babu also I interacted. They came to Indore for
Oh.
some executive meet.
Okay.
I've been meeting these people, particularly though I'm a structural engineer, but
Yeah. Yeah.
I'm doing consultancy in geotech nowadays.
Okay.
I'm comfortable in geotech, structures, building technology, and management. So I
Okay.
had three certificates in each.
Hmm.
topped in two. Now this will be 10th. Again, I'll try to acquire the top slot.
Yeah, yeah, yeah,
Let
sure.
us see how it works.
Yeah, sure.
And then uh, every semester I have one. I don't go in for number of certificates.
Mm-hmm.
One which is close to my working or which I like.
Okay.
Every time one.
Mm-hmm.
Sometimes it is challenging because this see, management course was a bit difficult. So many
Uh-huh,
new things.
uh-huh.
But I purchased the same book which the professor was following, read beforehand. One gentleman is from Jamia,
Yeah, Mr.
Nazrul
Najrul. Yes.
Kamar. Mr. Nazrul, good afternoon.
Good afternoon, Mr. Nazrul. Let other people also join. We'll start the session at 6:10.
Yes,
Mm-hmm.
yes. I had good interaction with Jamia when I
Oh.
was in Delhi.
Uh-huh.
I used to approach some professors for consultancy work given to them.
We'll wait till 6:10. If someone joins, then we'll start. Or else we'll start at 6:10 only. Good evening, Mr. Sarath. Maybe last class you didn't introduce yourself, right? Can you please introduce yourself, like in a very brief, what you're doing and all.
I am from Kerala,
Okay.
Trivandrum,
Mm-hmm.
and currently I'm doing MTech in Geotechnical Engineering.
From which college?
St. Thomas Institute for Science and Technology.
Okay. We'll wait for 2 more minutes and then we'll start. Okay, so we'll start the session. Good evening, Gopal Krishnan sir. Last class you didn't introduce us. Can you introduce yourself once? Then we'll start the session anyway. Maybe you introduced last class, right? I think. Not sure. It's busy. Okay, so we'll start. Good evening, everyone. I'm Balram Shah. I'm the PMRF TA for this course called Subsurface Exploration Importance and Techniques Involved. This is the discussion for week 3 lectures. I hope you guys have gone through all the video lectures of week 3. So,
Mr. Balram, you are not audible.
okay, sorry. Okay, sorry for that. So what I was, Mr. Gopal Krishnan, can you once introduce yourself? Then we'll start the session. Was- Okay. If you don't want to speak, you can chat also. No issue. Or else,
Probably he has joined, but he is not listening.
yeah. Okay, it's fine. Okay. Okay. Maybe he
Sir,
can
is
have.
my voice audible? Sorry, is my voice
Yeah.
audible?
Yeah. 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 Can you
Yeah,
please
sorry, sir.
introduce yourself once?
Sir, myself Gopalakrishnan, working as a lecturer in Oman, sir,
Oh,
Muscat, Oman.
okay. Okay. Oh, Tamil
Just
Nadu,
I
that
want to
one.
enrich my knowledge. I registered as a this course, sir, in
Okay.
my specialization. I'm working in civil engineering faculty, sir.
Yeah. Yeah. Okay. 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 Thank you.
Okay, sir. Thank you, sir. Thank you.
Okay. So we'll start the session. Okay.
Yeah, yes, sir.
Yeah. Good evening, everyone. I'm Balram Shah. I'm the PMRF TA for this course called Subsurface Exploration Importance and Techniques Involved. I am a PhD scholar at ICVAR Center for at Indian Institute of Science, Bengaluru, and this is the week 3 discussion for the week 3 lectures that we have seen. I hope every one of you have gone through the week 3 video lectures. So we'll start. Uh, so in the last lectures, I mean in the week 2 lectures, what we have seen was the vein shear test, the SPT test and all. And in this uh, assignment, what I have seen was there was some SPT questions also like to solve. So first of all, we'll start with the SPT. Okay, before that, okay, maybe. Okay, so before moving on, let's go back to SPT ones and see what we have done in the SPT test. Anyone who remembers how we have done the SPT test and all, and what all we need to do, or what was the IS code for the standard penetration test? Standard penetration test, or it is also called SPT test. So in SPT test,
IS
yes,
IS 2131.
IS 2131, correct. So okay, IS, sorry, 2131, which year? Here we can leave. Okay, so IS 2131, we used to do this SPT test. And why did we do this SPT test? To understand some parameters of the soil, right? What all parameters, what all characteristics of the soil? Anyone? What all characteristics of the soil we have seen?
Uh, Soil stiffness, moisture,
Okay, and
composition, structure.
Angle of internal friction.
yeah, correct. So these type of characteristics we have seen, such as we can go for first of all, what we do in SPT, we count the number of blows, or n, what we say SPT n. Okay, so in this we see or what all characteristics of the soil we can find out. Okay, like relative density, then what type of uh, angle of friction, what is the angle of friction for the soil if the soil is cohesionless. Okay, and other than this, we can go for moisture content and all. So many characteristics of soil we can do in this. So what we have seen in this, there was some kind of structure like this. There was one weight which we call the monkey hammer or drop hammer, whatever. Monkey hammer or drop hammer also we can, somewhere in some books they say. So this will be connected with some pulley or something, and here we'll be using this, and there will be one fixed anvil at a length of 76 meter or something. This one was the fixed anvil Okay, this is kind of cartoon only. Okay, some. So this will be and below this will be the drilling rod. Okay, so with which we if we put the dynamic loading, then what will happen? It will go inside and we'll get the in situ soil. Okay, let us say this is the ground level or ground surface. Okay, and this one is the drilling rod, and we go for how many blows? Sorry, how many meters we go in SPT test? We go for three successive intervals of 150 millimeter penetration. Okay, let me write penetration of 150 millimeter at three successive intervals, and we count how many number of blows it has taken. Okay, and so three successive intervals, that means n1, n2 and n3. And in the last discussion what we have seen, that we don't consider n1. Why so? Why we don't consider the first 150 millimeter penetration, whatever number of blows is there?
That is a sitting drive.
Yeah, sitting drive
Sitting
or
drive. It
sitting
may
count.
have error, so N1 is neglected.
Sitting count or sitting drive. So what is sitting count or sitting drive? Okay.
Particles get adjusted.
Yeah, there can be some
So
vegetations there, or some kind of disturbance will be there at the top surface. So that's why what we'll consider, we'll not consider this n1 number of blows. We'll only consider the n2 and n3. That is, to calculate the whole SPT, we'll consider only n2 and n3. Okay, and for getting the samples we use the split spoon sampler and all. And after we get this SPT n, what we do, we go for two corrections. What are those corrections?
The latency correction and overburden correction.
Yeah, so before dilating the connection, we have to go for overburden pressure correction. So first one is the overburden pressure correction. And how do we do this overburden pressure correction? We use the formula like n naught equals to n into, in some books there will be some different notations. Okay, in some books they use no or something, into 0.77 into log 2000 by sigma naught, let us say. Okay, so this one will be the corrections for the overburden pressure correction, and this n is the how much of the number of blows we have got for the second and third one. Okay, so and what is this, where is my pencil? Okay, and what is the sigma naught? Sigma naught is the effective overburden pressure, effective overburden pressure in kilonewton per meter square or kilopascal, you can say. After getting this overburden pressure correction in the SPT, what Mr. Nazrul says, we went for dilatancy correction. Okay, and why did we do this dilatancy correction? Anyone?
due to pore water pressure, there will be error. So it to account for that pore water pressure resistance.
Okay, so because of the pore water, what will happen, the condition of the soil will be the soil will be in saturated condition, and it tends to dilate when this n naught or whatever new n naught that we have got, if n naught is greater than 15 and the soil is in saturated state, then it can go to dilatancy phase. That's why we use this dilatancy correction. And how do we do that? Half into n naught minus 15 plus 15, and the last n correction that we get, we use as the SPT n value. Okay, so this penetration test measures what? Penetration test will measure the resistance to penetration of a sampling spoon under the dynamic, or it can be static loadings also. Okay, so we can understand the general exploration of the soil profiles, the strength, and the other properties of the soil. Okay, so I hope you got the SPT. Let us do the, okay, where is that? Okay, let us do one problem. Okay, so the question is, an SPT test was conducted on a clayey soil at 5-meter depth from the ground surface. So after the ground surface at 5-meter depth, we started the SPT test. The number of blows required for the first, second, and third penetration of 15 centimeter, 15 centimeter as we said, 150 millimeter, each were recorded as 11, 13, and 17. So this is N1, N2, and N3. Considering the groundwater table at the surface level. Now the groundwater table is at the surface level. So remember, if it is at the surface level, what will happen? The whole soil below the ground surface will be saturated, right? So find the corrected SPTN value for the location given saturated moisture content, that is omega or W equals to 24%, specific gravity G equals to 2.65, Cn. Okay, Cn is the correction over the because of the overburden pressure. Okay, in the where is that? I have shown, right? Where is that? Here you can see this 0.77 into log 2000 by sigma naught. It is called as Cn in the previous question. Okay, where sigma v naught is the effective overburden pressure. There I have used sigma naught, and no issue. And gamma w is the unit weight of water, 9.81 kg per meter cube. Let's do this. Use pen, paper, and whatever. And try to do this. Let's see what answer we get. Okay. Anyway, you have seen the option.
C is the answer, 37.
37. Okay, Mr. Shati says it will be 37. Others will wait for some more answers. Let's see. If anyone has completed, you can like tell the option, or you can also write in the chat box if you want. Did anyone else try? Like, anyone is trying, or like, should I move? See, if you are not getting, also you can tell me. I can then start or tell you how to do that. Okay, Nashul didn't get, and Gopal is saying 26. B. Okay, Nashul is not getting. Okay, so let's see. I will try once. Okay, see what we need. First of all, what all we have, n1 is equals. I'll remove this. Oh, sorry. What happened? भाई कैसे? Okay, so n1 is 11, n2 is 13, and n3 is 17. As I said, we'll not consider n1 because it is considered as sitting count. Okay, Abhishek is not getting. Okay, we'll see. So now the SPT value will be n equals to n2 plus n3, that is 13 plus 17. How much it is? This is 30. Okay, now what we have to do, we have to go for overburden pressure correction, and we have the formula as n naught, or n overburden, is equals to n into 0.77 into log 2000 by sigma v dash. And what is sigma v dash? Sigma v dash is the effective overburden pressure. So before getting the n naught, we have to calculate what is sigma v naught, right? So how we are going to calculate the sigma v dash? Mr. Satish or Mr. Gopal, how did you do that? How did you get this effective overburden pressure?
First, we require the value of E, porosity.
Okay.
For saturated soil, E will be equal to W into G. W is the moisture content in
Mm-hmm.
terms of fraction.
Okay.
0.24 into 2.65.
Okay.
So that gives me porosity value of 0.636.
Okay.
Now we require submerged unit weight. That will be equal to G minus 1 upon 1 plus C into gamma W. So value comes to 9.89. That is the same as effective
G,
saturated minus gamma W. That more or less becomes the submerged unit weight. So the
okay.
value comes to 9.89 into
Okay.
height.
Let's.
That gives me the overburden pressure.
Yeah.
9.89
Correct.
into
Correct.
H.
I got it.
The
So
same,
what?
same. Yeah.
Yeah. Let me do that. How
So
much we are getting? So for this, what it is given that the groundwater table in the question we have seen groundwater table is at the surface level. So my saturation value S is equals to 1. Correct. Now we know the formula ES equals WG, right? So this S is 1 anyway. Now E equals to how much? E equals to W is how much? 0.24 into G is how much? 2.65. So how much we are getting? 0.24 into 2, sorry, 2.65, 0.636. Okay, now what we have the soil layer like this, right? And let us say we have, okay, let's not draw that anyway. Okay, so what, how will we get gamma अरे color कैसे change हो रहा है gamma sat into my height. Okay, now how we are going to get this gamma sat equals gamma w do what was that g plus sc. So s anyway we have 1 g plus sc by 1 plus c. Okay, here also you can put wg and you can get, anyway let us put ea as we have found. Okay.
Mr. Balram,
Yeah,
instead of gamma saturated, we have to write gamma submerged because we are talking about effective overburden pressure.
yeah, so, sorry,
Effective means
yeah,
gamma
yeah,
W we have to deduct somewhere.
yeah, in the this here I have done problem. Okay, wait. Hmm. So what are you saying? Okay, so gamma sat is how much? Gamma w into g plus se, s is 1, so e by 1 plus e. How much we are getting this? G we have, e we have, and gamma w we have. How much we are getting? G is 2.65 plus e is how much? 0.636 divided by 1.636 into 9.81, something like 19.704 kilonewton per meter square. Okay, now here we have gamma submerged because anyway we are, our soil is saturated, so gamma submerged into height, that is gamma sat minus gamma w into h. Okay, calculate how much we are getting that. Anyone, how much we are getting this gamma v dash? Anyone? I have to calculate. Gamma site is how much? 19.704
19.704
minus
minus
9.81
minus 9.8,
into height is how much?
5 meters.
5 meters. It's coming somewhere near to 49.47 kilonewton per meter square. Okay, now we got the sigma v dash value. Now we can do the n0. Okay, I will take some other page. Mm. Okay. So our n naught is n into 0.77 log 2000 by sigma v dash. Okay, and sigma v dash in the previous, how much we have got? 49.47, right? Okay, 49.47. N was how much? 30. So 30 into 0.77 log 2000 by 49.47. How much we are getting?
1.24. 30 into 1.24.
So somewhere 37.11. Is it?
Yes.
Okay. Okay, so we can consider it as 37. And then we have to go for dilatancy correction. So dilatancy correction will be half into n naught minus 15 plus 15.
Uh, but this is clay soil. This dilatancy correction applies to fine grained sand, etc., not for clay. So dilatancy correction does not come in picture in this particular case.
Okay, but
That is
in
meant for fine sands, etc.,
no, but for
not
clay
for clay.
soil also we have to go for dilatancy correction, right? Because okay, no, we have pore water pressure here. We don't have that much of space.
That is meant for silt
Mm-hmm.
and fine sand,
Okay.
not for clay.
Okay. Question. Let me check once on the clay soil. Wait. So did in the last lecture did I use one question? I have given one SPT example, right? In that also did I made the same mistake? No, right? One question I have given in the
I'll
last.
just check up and tell.
Okay, okay.
1 minute.
But I should have that. But okay, it should not be the case in the clay soil. We have to go for dilatancy correction. On surface, the number of blows required for the
Uh, in your previous session, soil type was given as fine sand. In
then
that case, it is applicable. Now it
then
is clay.
then it's fine.
Last time it was okay.
Okay. Okay, so as the soil is clay soil, we should not go for this dilatancy correction. Why? Because see, if the soil is clay, what will happen? The pores that will be there will be very negligible, and hence the pore water pressure that will be there will not be that much efficient, right? So in case of fine sand or silty deposits, let us say, under the water table, it will exert an additional resistance to driving due to excess pore pressure that is generated, which cannot be dissipated during the test. Okay, so for that we need to do the dilatancy test for the fine sand or the silty deposits and all. So for this, the answer I have given as B, but that will be wrong, that is not correct. It will be C only, 37. Okay, is it clear to everyone why we are not doing dilatancy correction here? And thanks Mr. Satish for like stopping me there. Okay, okay, so we'll move to the, okay, understood, right? Okay, so we'll move to the next question. Okay, so the question is, which of the following statement or statements are true regarding the cone penetration test? Okay, before moving to the cone penetration test, this SPT test also we can calculate the relative density, and then we can calculate the angle of friction. So there are several formulas and all. So here I will write that, like if you want to calculate the relative density, okay, relative density or whatever, say like density of compaction and all, several researchers again have given different formulas. So it is given in percentage. So it was given as 11.7 plus 0.6 into 222 NF plus 1600 minus 53 sigma v dash. Sigma v dash we have seen 50 cu square to the power 0.5. Okay, so like this, let us say if we are going for cohesion-less soil and all, and we directly want to calculate the relative density, we have the void ratio, let us say. Okay, in that case also we don't have, like we are doing simply in the laboratory. Okay, we are not going for SPT test and all, and we know the what is the void ratio of the sample. From that also we can calculate the relative density. Okay, from that there was one formula like RD equals to something like E max minus E min by E natural minus E min. Okay, like this way also we can calculate the RD we have if we have the maximum void ratio, minimum void ratio, and the natural void ratio of the soil sample. But for the case of SPT, when we do the sampling, we use this formula. This was given by Marcuson and in 1977. Okay,
Mr. Balam, there is small mistake, you know.
okay.
Numerator and denominator are both the same. E max minus E. E minimum will not be there. It is E.
Oh, E max
And
minus E natural.
uh,
Yeah, correct.
yeah, and in the denominator, E max minus E minimum.
Oh, okay. Yeah, some kind of formula was there. Formula we can. E max minus E natural by E max minus E min. Correct? Something like this, right?
Yeah,
Yeah,
this
yeah,
is correct.
yeah. So this kind of formula we can use in the cohesionless soil when we have the void ratio for the soil sample, the maximum, the natural, and the minimum. And when we go for the SPT test, we use this formula, was given by some researcher. Again, after this also several researchers have given different formulas based on the projects and based on the uh, place and wherever we are doing, we can go for what formulas we want. Okay, where this NF that you can see, NF is the standard penetration N value that we have got. Okay, and sigma v dash, as I say, is the effective overburden pressure, and Cu is the uniformity coefficient. Okay, similarly for the angle of friction also we can calculate. Angle of friction phi equals 27.1 plus 0.3 and corrected minus 0.00054 something. Okay, this formulas and all you can check some digits or something I can misspell. Okay, so this kind of formulas has been given by several researchers, and after this also several researchers have given new formulas, and based on the structure of the soil, where you are getting the soil samples and all, you can get this will be in degree. Okay, like this you can get all the characteristics of the soil which we can get from the SPT. Now in the SPT, what we do in SPT, there are some of the disadvantages because of which we have to go for this CPT or the cone penetration test. What are those? in SPT, what we have seen in SPT, we uses the dynamic loading. Dynamic loading in the sense we used to drop that monkey hammer or the drop hammer to drive the sampler into the soil, and we used to measure the resistance, right? So we use the dynamic loading there. Now let us say when we are counting the number of blows, by mistake we have not counted the number of blows properly. Maybe we have counted some more number of blows or less number of blows, or let us say we have seen the height of the fall from the of the drop hammer to the anvil will be near 750 millimeter or 760 millimeter, something like that. Now what will happen, let us say we have not fixed it at 760 millimeter. Let us say 760 millimeter, I'm not remembering how much it was, 750 to 760 millimeter it was. So let us say now we have 760 millimeter standard. Now we have increased that, let us say we have made it 800 millimeter, and from that we are making the drop hammer fall. Now what will happen, it will take less number of blows because it is getting from larger height, right? So now if it is getting from the larger height, less number of blows will be there, and in calculation we will do some mistakes, not in the calculation, the number of blows only will have erroneous, and then we can have incorrect approximation of the characteristics. Okay, so what will happen if the height is larger, we can go we will have this underestimating of the characteristic of the soil. Similarly, if we have reduced the standard height, let us say 700 millimeter or something, then what will happen, then there will be overestimate of the characteristic of the soil. Other than this, number of blows, heights, what can be the thing, hammer efficiency, let us say. Okay, in hammer efficiency, how many number of blows we are giving that how many number of blows is for how many number of blows we are getting that 150 millimeter penetration, that can also affect. So because of all this, we have to go for the cone penetration test. Okay, so now in the cone penetration test, what we do, in the cone penetration test we get two parts, like the no, not the two parts, the cone will be there. Okay, we'll move to that and we'll see. First of all, this cone penetration test will help us in understanding the each of the components separately, like skin friction that is acting at the sampler surface, then the point bearing acting on the base of the sampler. Okay, okay, before that I will show you one video, it will be useful to you, like you can easily understand that.
So regarding SPT, the soil type and its density also influencing some values, no sir? It is either number of blows will be more or less. Like
Cone penetration testing is a fast, accurate subsurface exploration method. A CPT rig uses...
Sorry, I didn't get your question. Can you say once again?
Yeah, sure, sir. Can you hear me? Is it okay?
I can, yeah.
If the soil is clay or sand, whatever it is, sir. For example, the existing soil having some density, it is also influencing the SPT value. Am I right?
Yes. Okay, but
just I want to confirm that, sir,
because that is why we are going for SPT. No, if it is taking more number of blows in less penetration, we'll understand. Okay, this type of layer is there, right? So this relative density, and also we are calculating, and from that also you can understand what type of soil is there. Okay, okay. I'm showing a video. Can you see that? Can you guys see that? Okay, I didn't share the screen, sorry. Can you see the video?
Yes, sir.
Okay.
Cone penetration testing is a fast, accurate subsurface exploration method. A CPT rig uses hydraulics to push a steel cone into the ground. The cone is advanced at a constant rate. The instrumented cone records continuous measurements of tip resistance, sleeve friction, and dynamic pore water pressure. The data record allows for differentiation of soil layers and interpretation of material properties. The cone stops at refusal in dense soil or rock.
Okay, I kept this video so that you can like visualize it properly. Okay, so what we have seen in the video, if you have seen properly, first of all, what is cone penetration test? That is a very fast and accurate subsurface exploration method. 5 semi-direct method you have seen, right? So cone penetration test is one of them. Now you have seen first what we do, CPT rig will be there, okay, and from that this cone with the drilling rod and all will be pushed into. Okay, so what will happen, a CPT rig will use the hydraulics to push a steel cone into the ground. Okay, if you have seen in the video, there will be a steel cone. Okay, see this one is a steel cone. Okay, for standard cone penetration test it will have a proper value that I will show later. Okay, now what will happen, so this steel cone will be pushed into the ground. Now this cone will be advanced at a constant rate. Okay, now this cone will be advanced at a constant rate, that the instrumentation cone will record some continuous measurement as it is going into the ground. What will happen, you have seen in the right hand side there will be different graphs that were getting plotted. Okay, so that were the continuous measurement based on the how much cone is getting penetrated, and with that we'll get the in the rig only we'll have one system set up, and there we can get the plots and all. So what will happen, this cone is advanced at a constant rate, and the instrumentation cone will record continuous measurement of the tip resistance, the side one, the sleeve friction, and the dynamic pore water pressure. See in the video, if you have seen, there will be 3. Okay,
Cone is advanced at a constant rate. The instrumented cone records
see the red one. Okay, see in the tip you can see there will be a tip resistance, the QT that you are seeing, and again the FS you are seeing will be the sleeve friction, and there will be one dynamic pore water pressure. Okay, now this data will be recorded like this. In the upper there will be a rig and there will be system setup. There the data record allows for the differentiation of soil layers. Now see, if it is loose sand, what will happen, it will very easily penetrate. Then again for soft clay it will much easily penetrate. Now if the soil layer has been changed, let us say medium clay, so it will have some lesser it will penetrate little difficultly, right, than that of the soft clay. Okay, now based on this graph that we are getting, what we'll understand, the data record will allow us to differentiate between the soil layers, what soil layers are there at what depth, and interpretation of what type of material properties are there. And see at the end, let us say after medium clay we have rock. Okay, now this cone penetration, this or whatever the cone is getting, the cone will stop at the this dense soil or some rock is there, or dense sand medium is there where it cannot penetrate. There it will diffuse, or this cone penetration test will stop. Okay, you got it right? Okay, so now what I was there. Okay, so I will start in this. Now this CPT test was developed by Dutch government in the at the Delft University, so that is why this is also called as Dutch cone test. Now this CPT test can also be done in both static and dynamic. Okay, static means what? There will be simple push, that in the video that we have seen. Okay, there can be simple push. or the dynamic loading. As in SPT, what we have done, we have to push that, or we have to give the dynamic loading. Okay, okay, I have to resume this. Stop screen presentation. Okay, so what will happen? It can be static push also, that is thrust, or dynamic condition also, that as we have seen in the SPT. Sorry. Okay, so what is the question? Which of the following statement or statements are true regarding the cone penetration test? Cone penetration test can be easily performed in boulders and very dense sand. Then CPT helps in determining the skin friction and end bearing of soil separately. CPT measures the resistance offered by the soil right at the tip of the cone, or both B and C. What will be the answer? Okay.
So both B and
Both,
C.
both B and C, correct.
Okay, how to calculate corrected cone tip resistance, sir, can you explain? Okay, Mr. Gopal, we'll come to that. Okay, how to calculate and all. So for this, anyone other than Mr. Satish and Mr. Nazrul, what will be the answer? You can write in the
So
chat
both
also.
B and C.
Okay, 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 okay. So see, as we have just now discussed that CPT, what we do, we get the skin friction or the sleeve friction, the cone tip resistance, and the pore water pressure also. So in this, the answer will be okay. Measures helps in measures the resistance offered by the soil right at the tip of the cone. How many mistakes I have done? Soil tip of the cone. This will be both B and C only. Basically.
Yes, sir. Both B and C.
Yeah, yeah, it will be both B and C. Okay, maybe I mixed the options while making the presentation. Okay, no, no, no. See, Mr. Abhishek, first option is CPT can be easily performed in boulders and very dense sand. Just now I said that if it is very dense sand and boulders, the penetration will be stopped there only. We can't do cone penetration test for very dense sand or very dense soil or boulders, gravels and all. Okay, so the answer will be both B and C. Okay, next is which type of soil failure is caused by CPT while advancing into the soil? Okay, so before moving to that, anyway, we have seen the setup for the CPT, right? So what was the setup for the CPT? Let us say this was the ground level, and the drilling rod was inserted in this, like this, let us say. Okay, and this one was the drilling rod, which will have the sleeve friction, and this will have the cone. Okay, so here we have the sleeve friction, like this, let us say. And here we'll have, this is the steel cone, right? Okay, so okay, I will show you one more video. There we can understand what is there inside this. Okay, how to stop this?
Hello, I'm Professor.
Okay, so these are kind of the CPT test rigs that will be there, and from here we'll have the test done. Okay, so this is the CPT test rig. Okay, and now it will be inserted from here. Wait, to show. So now here is the test setup, and like this, see, this kind of push will be there. This is one kind of dynamic loading, right? Okay, we'll see that and then we'll discuss. Okay, so here what we have seen, see, if you see in this figure, you can see there are several different rods that are coming in. Okay, so these are called the push rod. So the cone is advanced to the desired depth by means of this thick walled push rod. See, this thick walled push rod is near to, oh, you can't see the screen. You can't see the screen. Hello?
Yes, sir, it's visible.
Visible.
Visible only, no? Abhishek, if you are having problem in
Visible.
seeing the screen,
Visible.
you can just once you can log out and then come. Okay, it's visible, right? Okay. Okay. So what I was saying, see what we were seeing here, we were having the dynamic loading, and here we have seen see several different push rods are given. Okay, so what is the why these push rods are given? This push rod are like 1 meter each. 1 meter to 1.5 meter will be there, and typically this push rod will be many will be screwed. Like we have some desired depth, let us say 7 meter. So what we'll do, we'll consider that okay, 7 push rods we need, so we'll bring that 7 number of push rods, and then we'll use that cable inside that, and then we'll push that inside, and at the bottommost the push rod at the bottommost the push rod will be there, and the cone will be mounted on a solid rod, and it will be passed through the push rod every time. Okay, here we have seen the dynamic loading. Similar kind of thing will be there in the static loading. It will be just pushed into that. Okay. Okay, so what we have seen, that the rig, this setup that you are seeing on above the ground surface, it is somewhat elevated from the ground surface. Okay, because there will be some horizontal thrust and all, right? So to protect that, we elevate that system, elevate that setup, so that we don't have any horizontal thrust. Okay, and this rig is then leveled using an external hydraulic jack. This is the external hydraulic jack, and this will have one instrumented probe, and it will be into the ground, and it will measure the force that the soil applies to the probe as it is penetrating through the ground. Okay, and this probe is pushed into the soil using a hydraulic jack. Here it is the hydraulic jack, and that will be located in this inside the truck. Okay, and the jack system will allow the probe to be pushed in a steady state. Okay, and then we'll have this whatever desired depth of investigation you have will go till that. Okay, then what we'll do, when we understand okay, now the probe cannot be pushed further. Okay, then we'll stop there. As we have seen in the last video, what we have seen, if there is dense sand or the boulders or gravels, whatever, after that we'll refuse that. After that we'll stop there only. Okay, and now okay, so this one will be the main setup that I have drawn last time. Okay, now this is the why it's not stopping. Okay, now this CPT probe will consist of 3 parts. First one is the 60-degree this conical tip. Okay, which measures the end bearing resistance of the soil. Then what we have a friction sleeve here, this side friction sleeve. What it will do, it will measure the side friction. And the third one is the will be the donut size, this flexible porous element to measure the pore pressure. As we have seen in that in the sides we have the pore pressure, right? Now to measure that, we'll have this flexible porous element to measure the pore pressure. Okay, now above this only the rods will be attached. Whatever rods that we have seen from 1 to 1.5 meter, that will be attached to this, and then it will be pushed using the static loading or the dynamic loading. Okay, Like nowadays this pore water pressure thing is there. Before that we only used to have this cone tip and the friction sleeve. Okay, nowadays we have so many things. Now this piezo cone, if you divide it, like if you slice it, what will happen? Okay, it's not coming. Okay, slice it. Okay, before that, see, we can have different size of cones for different projects and all. Okay, if you need more number of, like, what number of different sizes can be shared. All the four of the cones here are 60-degree angle. The cone will also always be having that 60-degree angle with the ground surface. Okay, and this smallest cone has a cross section area of 2 centimeter square, then 10 centimeter square, 15 centimeter square, like that. Okay, based on the project and all, we'll use the which size of cone we need. Okay, okay, okay. Now if you see, if we slice the inner part and if we want to see the inner part, then what we'll see that there are two load cells here. Okay, and before that the friction sleeve has a matching solder that is designed such that the friction sleeve bar bears on the inner rod of the solder. Okay, this much we don't need, I guess. Okay, these are the upper load cells and the lower load cells, and these formulas will come. Okay, that much is enough. Okay, so where I was, question. You got the test setup and all, right? What kind of procedure we use to understand the cone, means how we do the cone penetration test and all. You got the procedure, right?
Yes, sir. Yes, sir. But sir, in this test, we are not collecting any soil sample.
No, we are not collecting any soil sample. That will come later. Okay, first let us consider, let us understand how the procedure is there, and then we'll move that what are the disadvantages and advantages of this. Okay, so what we do the in situ measurements in this. Okay, okay, let me stop the screen here and we'll start it here. Okay, now what was the question? Which type of soil failure is caused by CPT while advancing into the soil? So what I was saying before going into that, this in the cone penetration test, what happens is this soil whatever is there, no, here we get the cone penetration at around 21 centimeter, 21 centimeter or something. What was the value? Something 21 centimeter, I guess. At 21 centimeter we get the passive failure. Okay, one failure we get, passive failure we say. Okay, so just add the cone. Okay, so the answer will be the correct only. See, in the previous question that we have seen, right, CPT measures the resistance offered by the soil right at the tip of the cone, but it's not the case. The soil resistance that will be there just at the tip of cone, that will not be measured, because in case of CPT what happens, at 21 centimeter after the cone tip we get the passive failure, and the resistance that is required at this point we get that. So the answer for this will be B only. Okay, how to rub that? Okay, so the answer for this will be B only. Okay, moving on to the next question. What was that? What type of failure will be there? So as I said, it's simple. What will be the answer? As I said, it will be passive failure only, because after some 21 centimeter and all, we'll have the failure that is called as passive failure. Okay, so for that we need to take cautions. The CPT will cause this passive failure of soil while advancing. So as a result, that soil, as I said, the soil will sense the resistance of soil that is available about 21 centimeter ahead of the tip, and not at the just at the right of the tip. Okay, and other than this, what all cautions we need to precautions will need to take in cone penetration test? let us say we have partially saturated cohesive soil. Okay, in that case additional friction will be recorded, so it will lead to some erroneous result. So we have to take cautions on that also. Okay, so what will be the answer for this? The answer will be passive failure. Okay, sorry. So the answer will be A. Okay. Other than that, there are so many parameters that we can calculate or get from the CPT test. Like what all other than all this? Anyway, we have seen that we can get the angle of internal friction or the drain friction angle. Then other than this, we also get the undrained shear strength, then the over consolidation ratio, sensitivity, okay, constraint modulus and all. So many things we get. Okay. So what is the main advantage of this CPT? Anyone?
So one advantage is that it is simple and easy to conduct.
Okay. Uh, other than that,
Continuous record is possible.
yeah, they in video what we have seen, the in the video what we have seen that there were some curves that we are getting, right? So in the SPT what we have seen, in every layers we'll get the data. Okay, but in this case what we are getting, we are getting the curves, like at the point if we have seen that curve now, let us say the dip resistance. So based on the depth, some this kind of, let us say for any layer, I'm just drawing some simple thing. We are getting here, 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 like this. What we are getting, we are getting the continuous record, so that not at all continuous, but at least near continuous record we are getting from the CPT test. So that is the main advantage of the CPT test, that for the whole depth that we are doing the exploration, we are getting the continuous record, so that we can understand, or we can, let us say two boreholes are there, and we have seen that okay, these are the layers. We can check there also whether the layers that we are seeing in between, we can check whether that layers are there or not. Okay, so the main advantage is it provides a near continuous record. Okay, provides a near continuous record. Okay, and other than that, as I said, the data we are getting is kind of in situ variety. Okay, so it is like good for the geotechnical design problems, and it is economical than SPT. And what are the disadvantages of this? These were the advantages. What are the disadvantages? Let us say, what is the main disadvantage?
The sample is not being collected.
Yeah, so in this case what we see, we do not retrieve a soil sample during the testing. Okay, so the anyway in like nowadays that is also not the case. The cone tip is changed with the soil sampler, and people can get the samples, but like previously we don't have this system. So that then we don't have, then that time we have this disadvantage. But nowadays the cone tip is also like changed with the soils, this sampler, and then we can get the soil samples if required. Okay, and again one more thing, like this transfer of data will be there, no, and there it will take time, transfer of data. Then again we are interpreting that data, what the kind of layer based on whatever graph we have. Okay, many researchers have given the, and this type of graph will be there for this type of soil and all. Based on that we'll interpret the data. Okay, and again it is not applicable for very dense sand, very dense soil and boulders and gravels. If there is there, we have to stop the CPT test there only. Okay, that's it for CPT test. After this, okay.
So there is a one disadvantage
Okay.
is that we cannot conduct this test everywhere in a small location. Suppose we have to conduct one penetration test in uh, in a dense area, so we cannot conduct this test because
Dense
it
area in the
requires a
sense.
dense area. Suppose in the city, in the town, where the setup
Okay.
cannot.
Okay. Okay. But see, if mainly we'll do the geophysical or geotechnical investigation where for some new projects and all. So mostly we'll get that location based on that only. Okay, so we generally don't go for that. Okay.
So the other disadvantage maybe is it is more costly than SPT.
No, it is much economical than SPT because we don't have to have that hammer and all. So okay.
But the market rate is more. Uh,
Okay, maybe as in the books and all it was there. I am not sure about the price in the market. Okay, so it might be possible. Yeah, it might be possible.
I think yes, it's most costly. So.
Okay, okay, okay. I'm not very much uh, sure about the market price. Okay, okay. So what was that? Next test was Venn shear test. We have gone through the standard penetration test. We have gone through, and then is the this what dilatometer test. Okay, so next one is the dilatometer test. So before moving on to the dilatometer test, anyone you must have gone through the video lectures, right? So in the dilatometer test we do the this in situ test again in the dilatometer test. What will happen, there will be one setup and there will be okay. I should have one video for that also. uh, are you guys okay with the video, or otherwise if I will draw and I will show? Which one you prefer? Because if you are understanding better with the video I will show that, otherwise I will draw and say.
No, so video will be better.
Okay, okay, thank
You
you.
may show your video itself.
Yeah, yeah, okay. Because I thought that in video it will be much clear, that's why I put some videos and all. Okay, let me see. Okay. Can you see my screen?
Yes.
Okay. Okay, so coming to the dilatometer test, this is the main setup for the not setup, the main dilatometer instrument that we have. It was given by Marchetti in 1980 in Italy. So in what we do in this, we'll get the in situ test by this. This is flat dilatometer. Okay, this setup and all will come. So this device is consisting of arrangements for lateral expansion after reaching a desired depth. So with this there will be a drilling rod. Okay, we'll see that. First you see the video and then we'll discuss on that. Okay, so this is the main setup, this is the rig. Okay, and now the preparations are going on. See here, you can see there will be a uh, upliftment of the rig so that we don't have any hydraulic thrust. Here they are doing drilling and all. Oh, we don't need this. Okay, okay, okay. Hmm. Okay, can anyone say what was that? These things they were doing something, right? These things they're doing something with white pipe or something. What was that?
They are inserting cable
Yeah,
for
this,
connection to the ground.
yeah, white kind of thing you are seeing is a cable. Okay, now at the end when we'll have the sensors that will sense all the resistance and all, that will come through this cable. Okay, if we are doing loose connections or we are having any problem in the connections, the data we'll get will be completely erroneous. Okay, so for each drill rod in the CPT also, what we have seen, I said no, there will 1 meter or 1 to 1.5 meter there will be drill rod which will push the main setup inside the ground. Okay, now this is these are also those kind of drill rods which will be around 1 to 1.5 meter. In each of the drill rod we'll insert the cable. Okay, and at the end it will be the diameter setup. Okay, let's see. This one is the main setup. Okay, this one is the flat dilatometer, and see the whole cable is inserted from this to all the how many. Now again the number of this drilling rod whatever we have, that will be based on the how much desired depth we have. Let us say we need 7 meter depth. Okay, so what we'll do, we'll consider at least 7 of the drill rod should be there, and then we'll move. Okay, we can't we have to pre-prepared for all this. Okay, now see, now it will be installed in the rig. Okay, now see in that, what is that? Here we will get all the records and all. Okay, the pressures that are there for P0 and P1. P0 and P1 readings, what are those? We'll discuss. Okay, don't worry. See, okay. So at every 20 centimeter, based on the standards, we'll have this P0 and P1 value. The P0 and P1, what is those? Will come soon. Okay, after this video. And see, now they will fix the drill rod, and then it will be pushed again. See, they are fixing the drill rod, then they will fix it with this apparatus, and then it will be pushed. See, it is getting pushed, right? So simply up to desired depth we have to push this. Okay, and we'll get the P0 P1 readings for each of the layer that we want. Yeah, that's it. That's it. Okay, so you understood the procedure, right? How they are doing the dilatometer test. Now we'll go move back to theory if it is clear. Okay, where is that? Okay, so what we have seen, there was one dilatometer, some flat dilatometer like this. Okay, my diagram you can be like, okay, it's not that great, but at least understandable. Okay, so what will happen, what we'll do, we'll just, if you see this by side, what will happen, this dilatometer that you are seeing, no, from the rig, what will be there, we will give some pressure. Okay, we'll give some pressure. Let us say the lift off pressure, we say the lift off pressure P naught, the lift off pressure that will be required to move the center, this dilatometer or the circle, hollow circle that you are seeing, it will be like will be bulged like this if we give the pressure. Okay, so what will happen, this lift off pressure will be required to move the center of the membrane in line with the blade. Okay, so let us say this is my blade. Okay, you can see this is my phone only. Okay, so this is my blade. What will happen, from this side and this side, it will the pressure will be given, and the membrane that you can see in the figure, the circle thing, that is a membrane. Okay, in line with the blade, it will come outside. Okay, and the lift off pressure that is required to move the center of the membrane in line with the blade for around 15 seconds will note it down, and that will be my P naught. Okay, next was the P1 or the P1 is the pressure that will be required to move the center of the membrane by 1.1 meter. How much? By 1.1 meter, or sorry, 1.1 millimeter of the soil. So the pressure that will be required to move the center of the membrane to the 1.1 millimeter of the soil, that will be considered as P1. Okay, this one will also be in 15 to 30 seconds will record. Okay, and now after getting the P naught and P1, what we'll do, we'll again deflate it. Okay, first we'll inflate and we'll see, first will be the lift off pressure, that the to the center of the membrane to bulge or to inflate in line with the blade. And the P1, how we'll calculate, the center will give the pressure when it is bulging or the inflating till 1.1 millimeter of the soil. We'll calculate the P1 value. Now after getting this, we'll just quickly deflate, and the blade is pushed to the next test depth. Again we'll go there, again we'll measure, and again we'll get the P0 and P1 value. So for each depth, let us say we are pushing that, we are getting the P0 and P1 value, again we are pushing, again we are getting the P0 and P1 value, simply till the desired depth that you want to know. Let us say up to the zone of influence of some foundation you want to understand. Let us say for 10 meter you want to understand, like simply you will push, and at every point you will understand, like at 1 meter, at 1.5 meter, and 2 meter, 2.5 meter, we will get the value of P0 and P1. Okay, and using that we'll go and get the characteristic of soil, the soil type and all. Okay, so what we'll do, we'll determine the rest lateral stresses, the elastic modulus, the shear strength of the sand, silt, clays, then over consolidation ratio, all these things we'll determine. Okay, so what all we'll determine, we'll determine the at rest lateral stress, then we'll determine the elastic modulus, the shear strength, then over consolidation ratio and all. Okay, and then see, after this two pressure gauge will inflate to 1.1 millimeter, how will we understand? The buzzer will be there on the rig, and that will be on, and then we'll understand, okay, 1.1 millimeter inflation has been done, now we have to stop. We'll get the P1 value, and again we'll take that value, and then we'll do the remaining whatever calculations we need to do, and whatever we want to understand, we have to understand that. Okay, so now using the field record and data reduction, what we'll do, we'll get the, let us say at point A and point B, or position A and position B within the soil, we have got the values or the data. Okay, so in this dilatometer test we have to go for calibration also. So ZM will be my gauge 0 offset. I'm not going deep because you might have gone through all the videos and all. ZM will be my gauge 0 offset, and let us say at A and B point we have recorded. So let us say del A and del B be the membrane calibration value. Okay, so how will we get P naught? P naught will get like P naught will be equals to 1.05, sorry, 1.05 A minus Zm plus del A. What was A? A is simply the, at position A, what is the record? Del A is the membrane calibration. After calibration we'll get the value. So del A will be the calibration value for at position A. Zm is my gauge 0 offset, and simply for B point also we have to do that, so it will be minus. Okay, so it will be minus. Mr. Gopal, can you please switch off your audio? So it will be minus 0.05 B minus Zm minus del B, and like this, uh, like this will get the P1 P minus Zm minus del B. Okay, now moving to that. Sorry. B minus Zm minus del B. Okay, so now first solve this question. What was the question? The question was, pressure in the dilatometer test is measured and recorded when options are the options. Options are, the membrane is in line with the blade, the membrane is moved 1.1 millimeter into the soil, the dilatometer blade is placed at the desired depth, all of the above, or both A and B. Anyway, we have discussed all this, right? So it will be easier for you guys to answer. When all we measure and record this pressure in the dilatometer test. Anyone?
All of the above.
Yes, sir, all of the above. Yeah.
Okay, that will be all of the above only. Okay, next, moving on to the next question. It's like, while performing an in situ DMT, the following observations are made. Consider del A as minus 28 kilopascal, del B as 48 kilopascal, Zm as 5 kilopascal, and groundwater to be located at the ground surface. Here it is given that groundwater is located at the ground surface. Find out the maximum value of the material index. Okay, now after we get the P1 and P0 value, simple formula we will use for material index. Okay, so material index ID equals, okay, I'll write in the next page, it will be better. Okay, so what I was saying, anyway, P0, as we have seen, it will be 1.05 into A minus Zm plus del A minus 0.05 B minus Zm minus del B, and P1 how you get? Only this one. Okay, so B minus Zm minus del B. So this material index will be written as P1 minus P naught by P1 minus U naught, where U naught is the hydrostatic pressure, simply the hydrostatic pressure. Okay, now what we have the depth, at any depth, what is the at what depth we have recorded the pressure at A is there, pressure at B, and for just to calibrate we have to do, right? So that's why we have pressure at C. When we are going for this what to say, other parameters such as the what all were there, let us say you want to understand the horizontal stress index and all, that time we have to calculate the effective overburden pressure or the overburden pressure that we have. So for that we need to have this calibration and all done, right? So for that we have to have pressure at other point also, at some other position. Okay, now we have to see what is the maximum value of the material index among all the soil layers. It might take some 5-10 minutes to solve, but then the next questions that we have, it is just based on formula. So can you please do this? At 7:40. Okay, we have less time, so better I will say what all we need to do. Okay, so what we have the depth. We'll make a table. We have a depth, we have P naught value, we have P1 value. Okay, P naught and P1 value, I mean we have the sorry, क्या हुआ? It's not working. Okay, anyway, so P naught and P1 we can calculate from this formula. We have at A what is the pressure, del A we have in the question, it is mentioned. See, in the question it is mentioned how much is del A, minus 28 kPa. Del B is given as 48 kPa and Zm is given as 5 kPa. Okay, and A in this formula that you have seen now, in here A is the pressure at A and B is the pressure at B. Okay, so A we have, B we have, C we have. Okay, now how we will calculate the P naught? We'll just use this formula in the above we have written, right? So we'll just put that values in this and we'll get the P naught value. Similarly we'll get the P1 value, and in the formula in material index, what we other thing we need, P1 we got, P naught we got, P1 we got, we need the U naught value or the hydrostatic value. So how we get that? U naught is equals to, we have the there will be one table given by sir, in that all the formulas are mentioned. Okay, C minus Zm plus del A. Okay, based on the third pressure, third position, what is the pressure, from based on that, in that you will get what all U naught value is there. Remember that you keep all the units in the same format, otherwise you might get some other answers and all. Okay, so let us say if you are working with bar, you will keep every unit as bar only. Okay, now using this formula, that is P1 minus P naught by P1 minus U naught, will get the ID value. Now all the values that we'll get, we'll take the maximum of that and we'll get the value for the this one. Okay, you got how to do that? Because we don't have much time, I have to go like this.
Yes, sir, we can do this.
Yeah. Okay. Okay, so from that we can get how much maximum value in the question it was mentioned, and that how much maximum value of material index was among the soil. So if you calculate, you'll get C as the answer, 0.30. Okay, you might check. Okay, it's clear, right, everyone other than Rishabh?
Yes, sir.
Yes,
Yes, please.
yes, sir.
See, I don't have much time, otherwise I would have solved it. Okay, moving to the next question. So what we can see, same question is there. Okay, same depth and same pressure, same everything. Just the question is, find out the minimum value of the dilatometer modulus among all the soil layers. Okay, again, so for the dilatometer modulus, how we can get that? Dilatometer modulus ED is given as alpha into P1 minus P0. Okay, and generally for clay soil, the alpha value is somewhat 34.7. Okay, or we can use the charts, and from there we can get the alpha values. Okay, generally for let us say that membrane that you have seen, no, in the center, if it is 60 millimeter membrane, so for 60 millimeter diameter membrane we have the alpha value as 34.7. Okay, again for different setup or different size, if you go, the alpha value will change. Now, so this ED or the dilatometer modulus is given as this formula. Okay, now in the previous here we calculated the P0, P1 for each depth, right? Now we'll use this formula, ED equals 34.7 into P1 minus P0. Okay, and we'll get all the value. Now from that, the minimum value what we'll get will be used as the ED or the dilatometer modulus. Okay, is it clear?
Yes, sir. Yes.
Okay.
Oh,
Okay, so the minimum value that you will get will be 8.7 bar. Okay, if you calculate. Okay, again same table and all is given. We have to find out the correct statement. Okay, so first one is no clay layers are present among the soil. Now see, based on this we can get several parameters, I said, right? We can get the over consolidation ratio, we can get these whatever we have calculated, like material index, dilatometer modulus, then horizontal stress index, we can get friction, and that is angle of friction, and all. Okay, again you remember this test is suitable only for clay, sand and silt. Okay, it is not suitable for gravels. However, like if the blade is strong enough to pass a gravel layer of 0.5 millimeter thickness or something, okay, only that much accuracy that and this is have. If the gravel layer is around 0.5 meter thickness, then only it can penetrate. After that it don't. Okay, so like this we can go for undrained shear strength, over consolidation ratio and all. Now can anyone tell me what will be the answer, whether it will be we'll get from this? No clay layers are present among the soil layers, no sand layers are present among the soil layers. Now based on this we'll have uh, uh, one diagram or one plot, it is given by several researchers. Okay, now based on the value that we have got, we can distinguish that okay, at this point, at this depth, one depth of 1 kilometer, my god, it is in kilometer. Okay, at whatever depth we have, what type of soil is present there, based on that graph or the plot that researchers have given. Now based on that we can understand whether it is clay layer, whether it is silt layer, whether it is dense sand, medium sand and all. Okay, and if you check with that, you'll get that no sand layers are present among the soil layers. You'll find all the clay layers is there, mud layer is there. Okay, but this sand layers are not present. Okay, got my point? Are you guys with me? Because I'm going somewhat fast because I have to go for pressure meter test also.
Yes, sir.
Okay, other than this one, everyone is getting right. Or I will,
Yes, yes.
I will go slow. I don't have problem in sitting for more than 2 hours. But see, I also don't understand why these 2 hours. People should get 1 hour only. 1 hour, 1 hour. We have to go because sitting 2 hours is difficult for the students. When at least when I am student. Okay. Moving back to the next question. Next is the pressure meter test setup. Okay. Before that, let us understand what are the advantages and disadvantages of this dilatometer test. Anyone? What are the advantages and disadvantages of the dilatometer test that you have seen? Anything that you have seen in the
The dilatometer test is simple.
it's simple only. Okay, it's simple and robust kind of thing. Okay. What are the disadvantages? One just
It,
I just said.
it does not work in boulders, hard soil, etc.
Yeah. What I said, it is only applicable for clay, silt, sand. For gravel also, if the gravel is around 0.5 meter depth, it can go if it has very good quality of blades. But after that, we can't use, like for boulders, for dense materials like gravels and all of very much thickness, we can't use this. Other than that, as we have seen, it needs calibration for the local geologies. Okay, so that is one of the limitation of this test. Okay, so now the last test is the pressure meter test. Okay, in the pressure meter test, what we do, anyway, all the subsurface exploration that we are doing to access the characteristic of the soils or rocks that is available below the ground level up to the zone of influence. Okay, now this pressure meter test was developed by Louis, spelling is correct or not, I don't know, Louis Menard. Okay, based on Louis Menard, there are several test type also. One was called Menard type pressure meter. Okay, Menard type pressure meter or MPM. Menard type pressure meter is the most common one. Okay, it will be lowered into the existing borehole. Let us say we have done borehole for some other case and we are lowering this Menard type pressure meter. And simply other types of pressure meter are also there, like self boring pressure meter, then push in pressure meters and all. Okay, so this pressure meter we do, and the biggest advantage is that in this test, in situ condition of the soil is there, like the test is done in the in situ condition of the soil. Okay, so what is the question? In pressure meter test setup, the pressure in the guard cell is dash in comparison to the measuring soil. Okay, before that, what is guard cell and all? Okay, there will be some kind of, let us say, borehole is there. Okay, we'll insert the setup. Okay, so there will be one kind of steel thickness, steel layer outside that. Okay, and this will be covered with two guard cells, one on the top and one on the bottom. Can anyone answer why we put the guard cell at the top and the at the bottom? Anyone?
To ensure no end effect.
Yeah, so if there is end effect, there will be some here. If some effect is there, we can have erroneous results too. So this guard cell we use to nullify the ended. Okay, so to nullify the end effect, we use the guard cell, and again in between there will be measuring shell. This is called as measuring cell, and this one are the guard cell. Okay, now again it will be also be pushed like this with the drill rod connected with that. Okay, let us say this one is the ground level. So there will be a connection of pressure, and one volume of water will be given and volume of gas chamber will be given. From that we'll see how much pressure is there for each of the volume. What it will be doing, it will give the pressure, okay, and the volume of the water will be expanding, and this measuring cell will inflate like this. Okay, now this guard cell will keep see, if we don't keep guard cells, what one more thing can happen. Well, like, what end effect can be there, it can bulge like this here, the soil, right? So for this we use the guard cell, and so that if the bulging happens in the measuring cell, it will not affect the layer in the guard cell. Okay, so it will inflate like this. Now at what was the value, at some pressure level for 10 kilonewton per meter square or something, at that pressure level we'll stop and we'll see how much volume is required, and based on that we'll get the deformation. Okay, and then we'll have the volume to pressure plot. Okay, so you have seen in the consistency limit and all, right, for soil, but for like if you going depth of the soil, what you will see, some kind of plot like this you will observe. Okay, if you start from 0, this will be VC. After some point it will go as linear. Okay, this kind of linear. So this will be my V0. Okay, this will be my VF plus V0, and if you say at the end when it is hitting, that will be my, let us say, the limit or the VL, if you say. Okay, I'm not going deep into what all these are there because you might know all this. PF, this one will be P0. Okay, so what we know that this measuring cylinder or the flexible membrane will be covered by a protective material. That let's say the outside that you see, this thing, this part is covered by a protective material. It is called as Chinese lantern. Okay, such as maybe steel strips to prevent the membrane from wear and tear, because when we are doing this test, what will happen if it is bulging and getting, the soil layer will be there. If we are getting every time on some soil layer or rock layer, what will happen, wear and tear can happen. So for that we use this Chinese lantern, so that the wear and tear will not affect that much. Okay, so I'm not going deep into that. For different type of probe or different type of designation, there are different, what is the diameter of the probe, what will be the length of the measuring cell, what will be the volume of the VC and all, it is given. Okay, let us say for some case, so this, so V0 is what, V0 is the volume required. Let us say some point is that T, some point A, so V0 is the volume required.
Mr. Balram,
Yeah,
may I
yeah.
interrupt one question? In this graph, P versus V,
Hmm.
when they presented in the lecture,
Hmm.
they showed the value as VC, V0. Next one they wrote as VF plus V0. VC also they wrote here. VC plus VF plus V0.
Yeah, yeah, VC will be there. Okay, yeah, VC will be there. Like, what is the volume? If you see from here to here, if you go, maybe in the figure they have no, in the lecture they have not started with 0, I guess, right? Okay,
Yes,
whatever. Let us say I have started with 0. Okay, so from one volume VC it is starting. Okay, now what will happen? The volume, for just to contain, let us say this soil is there. Okay, if borehole is there, not every time the soil will be intact with the perimeter of the borehole. What will happen, it will somewhat it will disturb, will get disturbed, or it will get somewhat bulged. Okay, so that will be taken into consideration, and when this measuring cell will be inflated, that will be taken into consideration. Based on all that, anyway, we have gone through all these videos, I'm not going deep into that. So there will be the volume of cavity, this VC that you are saying, no, just to the pressure that is required for the when we are inflating. Okay, what is the volume that is required to just inflate this cavity, that is called as VC, and the pressure there is called as pressure at cavity. Anyway, that is considered as a starting point only. Okay, so that's why they have not in that lecture sir has not considered PC, because anyway in the procedure we consider PC as the starting value. Okay, because it is just at the volume of cavity, at the cavity to fill that how much volume is required. So that is considered as the volume of the cavity. Okay, when let us say we are or we can say the deflated probe volume also. Okay, now these are the P naught, PF and P sorry, I have written correct only na, this is L. Okay, so P naught, PF, PL will in the dilutometer, as we have seen, three positions we have taken, A, B and C. Like that also in this also we will consider three position A, B and C, and then we'll get this P naught, PF and PL at A, B and C pressures. Okay, now in this we'll calculate so many things, such as the Maynard sheared modulus, GM or EM we write. Then we calculate the pressure modulus, pressure meter modulus and all. Okay, what was the question? In pressure meter test setup, the pressure in the guard cell is dash in comparison to the measuring soil. What will be the answer? Sorry.
Less.
Equal.
And why equal? Who said that equal? If it is not equal, let us say the pressure in the guard cell is not equal to the measuring that of the measuring cell, what will happen? It will not be less, because if it is less, the pressure in the guard cell is less, what will happen? The measuring soil is having high pressure, okay, and the guard cell is having a low pressure. There can be slight bulging at the end, so that's why we have to have equal pressure that of the guard cell. Okay, moving on to the next question. Which of the following statement is correct for the pressure meter test? Options are: measured cell is inflated by using water pressure, guard cell is inflated by using water pressure, measured shell is inflated by using gas, guard cell is inflated by using gas, both A and D or both C and B. Measured shell means that measuring cell in between. Okay, so I'll give the answer. So both the measured cell and the guard shell will be inflated using the water pressure, whatever water we are using for that. Okay, next is some problem is there. In a borehole of 60 millimeter diameter, a pressure meter test was conducted at 3 meter depth from the ground surface on a clay deposit, and the reading of the pressures and the injected water volumes are given below. Find out the pressure modulus, that is EM. Anyway, pressure modulus EM, we know the formula. EM is equals to 2.66 Vc plus V0 plus Vf by 2 into Pf minus P0 by Vf minus V0. Okay, this will be the pressure meter modulus, or you can say Maynard pressure meter modulus. Now what we'll do, we have the pressures, we have the volumes. Can anyone, you don't have to solve, can anyone just say how we are going to do this?
We have to draw a graph first.
Yeah, but in the, let us say in your final exam and all, if question is coming, they will give all this value. Okay, because they just want to understand whether you are keeping the units correct or not. Okay, the pressure and volume, will just plot the pressure and volume graph as we have seen. Okay, pressure and volume graph will plot, and we'll get some kind of whatever we have seen, right, like this. And from this we'll get all the value, that is Vc, V0, Vf and all, right. Now from there, just remember that units should be considered properly in the exams also. If you don't consider units properly, you might land to some wrong answer. Okay, so what they want is to understand the proper problem, and then you have to do that. Okay, so using this plot, we'll get the V0 Vf value as we have seen in the, where is this, yeah, this plot. From this plot you'll get all the value. Can you see? So V naught, Vf, Vc and all you'll get, and you just put in the formula that we have. Where is that formula? Yeah, this formula you will put, and then you will get one value. Okay, one value, and I have given one range, so in that you can get, you might get something 98 or something. Okay, moving on to the next question. Same table is there. Okay, in a borehole of 60 millimeter diameter, a pressure meter test was conducted at 3 meter depth from the ground surface on a clay deposit. The reading of the pressure and all are given. What would be the Young's modulus of the soil? Simply, if you have this EM value, how will we calculate the Young's modulus? Simply E equals to the pressure meter modulus divided by alpha. Alpha is based on what type of soil you are considering. For different soil we have different values for the alpha values. Okay, let us say here it is given that it is clay deposit, right? For clay we have alpha as 0.67. Again, let us say for normal consolidated soil, if you have over consolidated clay, or then the alpha will change to 1. Okay, then if it is, let us say, normal consolidated silt is there, then for that alpha will become 0.5 and all. Now if we have EM value, we can simply calculate the E, that is the elastic modulus. Alpha is how much? 0.67 it is given, so it will be somewhat, okay, it will be B. Okay, next question I have. Okay, that's it. Okay, that's the last question. And other than that, what all we can calculate will be the, let us say, undrained shear strength you can calculate, and then Cu you can calculate. How you will calculate the Cu equals to PL by alpha. Okay, like this. So what is the main advantage and main disadvantage of this test? Anyone?
Number of properties we can find.
What type of properties?
Soil properties such as modulus of elasticity, etc. All
Yeah,
those
yeah,
things can be found.
correct. So we get all the elastic modulus, the pressure meter modulus and all. Okay, and in this what we see that a significant number of, or the volume of soil and rock we are observing and all, right? Okay, and what are the disadvantages? Simply it cannot penetrate gravel, and thus required the drilling mechanism. If we have the drill bore, then we can go for this test. Okay, again, as now we are going to more sophisticated tests and all, we have to have skilled people to uh, see whatever is going correct or not based on the standard test and all. Okay, so these are some kind of advantages and disadvantages of this test. Okay, the rocks and all will come in the next lectures and all. I think the we
Sir,
yeah,
sir,
yeah.
sir, where we are going to use the pressure meter modulus from this test, pressure meter test?
Okay, let us say you have to have keen observation on the volumes based on all the pressures and all, and that how much volume is getting. Again, see, in the advantages only we have what we have learned, that it has different fundamental properties that can be determined. What are fundamental properties like elastic modulus and all. If we want to know all these things, then you can go for this pressure meter test. Okay, based on what you need, you have to go for what test you want.
Okay. Sir,
Again it
but
will be
in
okay, let me
sir,
complete. Okay, let us
okay,
say
okay, sir.
you want to understand the let us say you are going for some loaded piles, laterally loaded piles. Okay, you want to understand the performance behavior of those piles. Okay, for that also pressure meter test is very good. Okay, again you don't have to go for that in the last test, that is dilatometer test. You have to have the calibration of that membrane. Here if for some point, for some phases we have to go for calibration, but that for numerical models and all. Okay, so these are kind of when we use this pressure meter test and all. I hope I explained your answer. So there are many formula. Do we need to remember all? No, Srinath, you don't have to remember all those formulas. Small formulas you can remember. The formulas will be given in the exam mostly. A small formula you remember, like this elastic modulus is pressure meter modulus divided by alpha and all. You remember alpha values and all. You don't have to remember, one or two you remember. That will be enough, because in the exam they will give formula if required.
Yes, sir. There's a lot of formula
Yeah, formula is
in
there.
every test.
See, big formulas are there and you have to use that. That will be given. Don't worry.
Okay.
Sorry for exceeding time. Okay, I have exceeded so much of time today. Next time I
No,
will.
sir. It's okay.
Next time I will see. And today I have to go somewhat fast also. Okay, sorry for that. I hope you guys understood and all. Is there any other doubts? Any other doubt? Anyone? Rishabh, Mr.
Yes, sir.
Shadis?
In the next class, sir, please let me know that why we will go for the CPT test, cone penetration test, rather than using the SPT test.
That
In
I
the next
have
class,
told in the beginning only, na. Why we are going for CPT test? See, in the SPT test there are some disadvantages. Let us say we have to have proper hammer efficiency. Then, if we are increasing the number of blows, if we didn't observe that okay properly that this number of blows is there, okay, so that can give erroneous result. Okay, and that can lead to overestimation or underestimation of the soil properties. Okay, let us say if you have increased the height or decreased the height of from the standard, that also will lead to erroneous result, and that will in effect it will what will it will do, will understand the soil properties at something else. Okay, so for that we have to go for cone penetration test. Plus, in the standard penetration test what we have seen, we have only used the dynamic loading like this. Okay, but in cone penetration test we can go for static cone penetration test also. In static cone penetration test we can go for some in situ also you use. So like that, for all those reasons we use go for cone penetration test.
Okay.
Okay,
So this means we should not use the SPT test for any kind of a structure.
what?
For for any kind of construction, we should not use the SPT test.
No, if you are going for proper SPT test, no, it can give good characteristics. uh, so if you like skilled people are there, you they will go for SPT test also. It depends on the projects and where you are doing that. Okay.
Okay, sir.
Okay, any other question?
Well
No, sir.
presented.
Okay, thank you. I hope everything is clear. I went too fast because we have time constraint and all. Okay, so we'll next Monday again. Thank you everyone. We'll next Monday this link only at 6 o'clock. I hope the video and all that I have put was useful for you, because I thought that drawing 2D and all it will be difficult, so I put that videos and all. Okay.
That was excellent. Excellent.
Okay. Okay. Thank you. You guys can leave now.
Thank you, sir.
Okay.
Okay, thank you, sir.
Okay. Thank you.